In this section, I'll talk about dispersion and diffraction. Now, I didn't put them together because of any particular commonality between them. I put them together because they both start with a D, and for that reason, we might tend to confuse them if we don't specifically make a distinction between them. Now, dispersion, which I'll talk about first, is the separation of polychromatic light. Now, polychromatic means many colors, so the white light that comes from the sun is made up of all the colors in the rainbow. The white light that comes from the sun has red light, orange light, yellow light, green light, Roy G. Biv, you know. So dispersion is the separation of that polychromatic light into its individual colors. Now, why do they separate? Well, they separate due to differences in the index of refraction. Yes, dispersion is a form of refraction. It's a special form of refraction. So why do these colors separate? They separate due to differences in the index of refraction for the different frequencies. The red light, the orange, the yellow, the green, the blue, the indigo, the violet are all different frequencies, and this actually causes them to have slightly different indices of refraction and to bend to different degrees, thus causing them to separate. Basically, dispersion means making a rainbow. But don't write that on the Regents exam. Write something more like this. Okay, so let's just take a look at a drawing of a prism. Now, maybe you've seen a prism. It's usually a little triangular piece of glass. And when the light comes through it from the sun, that light will be separated into its component colors. So here's the white light from the sun. Right, the white light from the sun. And when it comes out, now I only have 3 colors here. I've got red, I've got green, and I've got blue. So we're just going to have to make do. All right, when the light goes through the prism, the red refracts a little bit. The orange and the yellow, I don't have those colors, but the orange and the yellow refract more. The green refracts more than the yellow. And then the blue, the indigo, and the violet refracts the most. So our rainbow would be red, orange, yellow, green, blue, indigo, and violet. All right, so again, dispersion is just a special form of refraction where the red does not refract as much as the violet. The violet refracts the most. Okay? So this is dispersion. Now let's look at diffraction, right, which is completely different. Diffraction. The only thing they have in common is they both start with D. And they're both wave phenomena. But other than that, we're not going to get them confused. All right, here we go. Definition for diffraction. Diffraction is the spreading of a wave when it passes through a slit a slit or an opening, through a slit or around a barrier. Diffraction is the spreading of a wave when it passes through a slit or around a barrier. Okay? So let's draw a picture of diffraction. Okay. This is called single slit diffraction. Right, there's the slit, the opening. Basically, these are barriers. Right, this is a barrier and this is a barrier. So you almost can't have the slit without the barriers. So the definition is a little bit redundant. Now, here are waves. These are what we call wave fronts. All right? These are wave fronts. Now, what a wave front is a bunch of crests all together. So it would be like crest, 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 crest. Like at the beach. Crest, 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 crest. Generally, we use a solid line to represent crests, and the troughs would obviously be between the crests. So you can draw in the troughs as dotted lines, or just leave them out in this case. We'll leave the troughs out for now. When we do double slit diffraction, we'll put the troughs in then. Now, what happens is that the wave passes, now the wave is going in this direction. The wave is traveling in this direction. The wave will go through this slit and then start to spread out. So it's going to look like that. There's your crests. Right, there's your crests. There's your crests. It's almost as if the wave started from this point and spread out from this point. Right, so that is a diagram of diffraction. D-I-F-F-R-A-C-T-I-O-N. Now, what I'd like to do is show you all the different little diagrams of all the different wave phenomena so that hopefully you won't get them all mixed up. All right, so let's look at all the different possibilities. We've got reflection. We've got refraction. We've got dispersion. Now remember, dispersion is a form of fraction. We've got diffraction. Okay, so here's a barrier. In reflection, the incident ray comes down, and there's your reflected ray. Reflection is when a wave bounces off a surface. Now this could be glass, for example, and this could be air. Notice that in reflection, the incident ray and the reflected ray are in the same medium. They're both in the air. They both stay in the air. Right? And the incident angle and the angle of reflection are equal. Now in refraction, you've got glass again and air, or any two media, but what's different is the incident ray comes down, and instead of reflecting off the glass, it passes into the glass. But it does not go straight. It bends toward the normal, in this case, Because glass has a greater index of refraction than air. Now, in this case, theta I is greater than theta refracted. The incident angle is greater than the angle of refraction. And also, the way that this is different from reflection is that the incident ray is in one medium, the air, and the refracted ray is in the glass. It's different from reflection. Now, dispersion is a form of refraction because the rays are bending. Bending, 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 bending. Dispersion is a special form of refraction where all the different colors that are here separate on this side. This could be red, orange, yellow, green, etc. Now, diffraction is when there is a slit. I'm going to do it in this direction. There's the slit. Here come the wave fronts in that direction. And they squeeze through this slit. Here's the barrier. Here's the barrier. And the waves squeeze through the slit. And it's as if they're starting from right there. And they spread on the other side. That is single slit diffraction. Now, I want to show you one more example of diffraction, just very briefly, because in the next section I will talk about this double slit diffraction in much more detail. But I do want to show you a picture of double slit diffraction for a specific reason. Now, I'm going to have to erase a little bit of my refraction here. I think I'll have enough room right here for double slit diffraction. This is single slit. Over here I'm going to do double slit. So here's one slit. And here's another slit. Two slits. Here come the waves. They're going this way. Remember, these are wave fronts going this way. So they're going to squeeze through here, and they're going to squeeze through here. Now this time I'm going to draw the crest and the trough, and the crest and the trough, and the crest and the trough. Okay? And over here, the same thing, a crest and a trough, and a crest and a trough, and a crest. Now, this is double slit diffraction. So it's definitely an example of diffraction, just like this single slit diffraction. What's different here is that in addition to diffraction, you also get interference. Right here, remember, a solid line is a crest, a dotted line is a trough. So right here, where crest meets crest, you have constructive interference. Here also, where trough meets trough, you have constructive interference. Remember, crest, crest, constructive. A solid line with a solid line, crest, crest, constructive. Trough, trough, a dotted line with a dotted line. See how they're meeting here? They're crossing. That's also constructive. Where is the interference destructive? Where a crest, here's a solid line, meets a trough, here's a dotted line, that would be destructive interference. So I will show you this again, a much larger diagram, in the next section, in the section on constructive and destructive interference with double slit diffraction. But I just want you to see that this is both diffraction and interference. So let me write that down. This is diffraction and also interference. Remember, what we're doing here is looking at all the different pictures so you won't get all these pictures mixed up. All right, now I can do one more example of interference because I've got a little space right here. If I'm poking my finger in the water right here, poking my finger in the water, you know that there's going to be circles of waves coming away from my finger. Now I'm only going to draw the crests. All right, now what if I was poking both of my fingers in the water right here? All right, you're going to get circles there moving away from your finger. Again here, you have an example of interference. These waves are interfering with these waves. They're both in the same place at the same time. Now, in this case, I'm only drawing crests. So crest meets crest. This is constructive interference. There will be destructive also as well. So, this is another example of a drawing of interference. Okay? So just to recap all the drawings. Reflection, boing, the wave bounces off of a surface. Refraction, the wave passes into the surface, the glass, or whatever it is. Dispersion, a form of refraction. Oh, again, reflection is the bouncing of light, boing. Refraction is the bending of light. The bending of light when it enters a new medium. Here, dispersion, a form of refraction because the light is bending, but because green bends more than red and purple, violet, bends more than all of these colors, they will separate. The different colors will separate. Dispersion, a form of refraction, the bending of light. Diffraction. This is diffraction. This is diffraction. Single slit diffraction, double slit diffraction. This is when light passes through a slit or around a barrier. There's the barriers, there's the slit, and spreads out on the other side. Now, when you have double slit diffraction, because you're getting this set of waves interfering with this set of waves, you have diffraction and interference on the same diagram. Now, the Regents exam will never make this confusing. If you see a picture of a prism, there's not going to be two answers that say dispersion and refraction. It's going to be one or the other because that would be a really bad question. They won't do that to us. If you see this diagram, you're not going to see diffraction and interference as two different choices because, again, that would be a bad, confusing question. All right, so this is showing diffraction and interference. This diagram would be if I was poking my fingers into water, for example. And you would have a set of waves around my one finger and a set of waves around the other finger, and the waves from this finger and the waves from this finger would interfere with each other in the center. All right? So I hope that seeing all these little pictures on the board at the same time will help you not to get them all mixed up. All right? Because these are nice, easy questions. They ask you, what is this diagram showing? And you tell them, this diagram is showing reflection, this is refraction, this is dispersion, which is a form of refraction. This one shows single slit diffraction, diffraction. This one shows double slit diffraction, diffraction. There's also interference there. This one shows just interference. Got it, right?